Hey everyone, and welcome. Today, we're not just going to talk about Kubernetes security, we're going to build a fortress from the ground up. We're going to go layer by layer, and I'll show you how to turn your cluster from a wide open field into a truly impenetrable stronghold. So let's get right into it. So let me start with a kind of scary question. Is your Kubernetes cluster an open house? Because here's the thing. A default, out-of-the-box cluster pretty much is. By design, any workload can talk to any other workload. That's great when you're just starting out, sure, but for anything real, it's a massive security hole we have to plug. And this visual just says it all, doesn't it? On the left, you've got this chaotic free-for-all. Everything is talking to everything else, no rules, no structure. On the right, though, you have order. You have a fortified system where every conversation is deliberate and controlled. Our goal today is to get you from the left side to the right. So, here's our game plan. This is the blueprint for our fortress. We're going to start with that big outer perimeter wall. Then, we'll build some walled districts inside. After that, we'll assign gatekeepers and protect the keys. Then, we'll armor up our core assets. And finally, we'll see how the whole thing looks when it's all put together. It's a classic layered defense. All right, first things first. Every good fortress needs a massive perimeter wall, right? In the world of Kubernetes, our wall is built using something called network policies. They do exactly what you'd think a wall does. They control who gets in and who gets out. Let's imagine a super common setup, a 3-tier app. You've got your front end, your back end, and your database. Now, logically, the only traffic you want is from the front end talking to the back end, and then the back end talking to the database. You absolutely, under no circumstances, want your public-facing front end to be able to talk directly to your database. So how do we enforce that rule? We do it with a policy that looks just like this. And don't worry, let's break this down. It's actually super simple. This policy targets any pod that has the label app backend. Then the ingress rule says, I will only accept traffic from pods that have the label app frontend. And here's the magic part. Because we've applied this policy, anything else that tries to connect to the backend is automatically blocked. Simple, right? But so powerful. That's our first wall. Okay, so the big takeaway for this layer is to think default deny. Block everything first and then poke very specific holes for the traffic you actually need. And one quick heads up, Kubernetes doesn't enforce these rules on its own. You need a network plugin, a CNI, like Calico or Cilium. Think of them as the guards who actually patrol the wall and make sure everyone's following the rules. All right, our perimeter is secure. Let's move inside the walls. For our second layer, we're going to build walled districts within our fortress. This is where we use namespaces and resource quotas to keep different teams and applications from stepping on each other's toes. So what's a namespace? Just think of it like a dedicated district inside your kingdom. It's a virtual wall you put up that keeps Team A's stuff totally separate from Team B's stuff. This is so important because it means a security breach or even just a bad deployment in one district doesn't take down the entire kingdom. But just giving them separate districts isn't enough. What if one team gets greedy and tries to use up all the resources? That's where resource quotas come in. This is like setting a budget. You're telling Team A, look, your district gets 20 pods, 10 CPUs, and 20 gigs of memory. That's it. Use it wisely. This prevents one buggy app from starving everyone else and crashing the whole cluster. An approach up here always create separate namespaces for your environments. Dev, staging, production. This is just non-negotiable. And when you combine this idea with the network policies we just talked about, boom, now you have true multi-layered isolation between your environments. Okay, so we have our outer wall and we have our internal districts. Now we need gatekeepers who decide who can do what. This next layer is all about something called RBAC, role-based access control, and handling the keys to the kingdom, your secrets. RBAC sounds really fancy, but the concept is beautifully simple. A role is just a list of rules, like you are allowed to look at pods. And a role binding is the thing that assigns that list of rules to a person or a program. That's really it. You've got the rules, and you've got who the rules apply to. And when you're writing those rules, this is the absolute golden principle, least privilege. Don't give your deployment pipeline admin access to the entire cluster if all it needs to do is push an app to one little namespace. Give every single person and every single program the absolute bare minimum permissions it needs to do its job and nothing more. Now about those keys, Kubernetes has a built-in object called secrets, but, and you really need to hear this, by default they are not encrypted. They're just base64 encoded, which is basically a flimsy disguise, not a lock. For any serious work, you should be using an external secrets manager like HashiCorp Vault or one from your cloud provider. Those are actual hardened vaults for your credentials. So you have to practice good secret hygiene. Rule number 1, never, ever, ever check secrets into Git. Just don't. You should also rotate your credentials regularly, and even better, whenever you can, use temporary credentials like IAM roles instead of long-lived static keys that can be stolen. We've secured the network, the namespaces, and who has access. It's time for our final layer of defense, armoring the workloads themselves. This is all about controlling what your applications are actually allowed to do once they're running inside the fortress. Kubernetes gives us a great tool for this called Pod Security Admission, and it has 3 levels. Privileged is the Wild West. You can do anything. Avoid it. Baseline is a pretty good starting point that blocks a lot of common risks. But restricted, that's the gold standard. It's the highest level of security, enforcing a whole bunch of best practices on your running pods. And the best part is how easy it is to turn on. You can enforce that super strong restricted profile on your entire production namespace with this one single command. You just label the namespace, and that's it. From that point on, the Kubernetes API server itself acts as a guard, and it will flat out reject any new pod that doesn't meet those strict security standards. So, we did it. We've built our walls, we've organized our districts, we've assigned our gatekeepers, and we've armored our core. Let's take one last step back and look at how all these layers work together to create a truly secure Kubernetes fortress. And here it is, all laid out. Our network policies are the firewall. The namespaces give us internal isolation. RBAC controls who can do what. Pod Security Admission hardens the actual workload, and Solid Secrets Management protects our credentials. See how each one has a specific job? They're strongest when they all work together. If there's one number to take away from all this, it's 5. 5 key layers. Security is never about one single magic bullet. It's about defense in depth. The whole idea is that if an attacker somehow gets past one layer, there are 4 more waiting for them. We're making their job as difficult as possible. And that really brings us to the most important point. Building this fortress isn't a one-time thing. It's an ongoing process. So I'll leave you with a question to think about for your own setup. Looking at these layers we've built today, which part of your fortress are you going to go strengthen first?